In today's episode of Fun Fact Friday, this week at the Trust Insights Annual Summit, which was held in my dining room because we're a startup, um, we were talking about some of the different ways that you can do data tasks like feature engineering, because the ability to use topic modeling and text mining and all of these different machine learning algorithms is contingent upon what you put into the algorithm. The more data that you have that's valid, clean, compatible, chosen well, the better the algorithm will perform. When you think about it from that lens, then, the average piece of text that you feed to an algorithm isn't very rich. For example, take a tweet, right? 280 characters at most, probably 10, 15 words. That in and of itself, there's not a lot in that. It's just a bunch of words. What are the things that you can extract from that that could help you to better understand it, better quantify it, and build better predictive algorithms around it? Feature engineering is a data science term which means, well, it's engineering features. A feature is a dimension. If you think about putting a tweet in the first column of a spreadsheet, right, and you put all your tweets in one column, that is one feature, the text itself. What other columns could you add to that spreadsheet that would be meaningful, that would describe the data that you could engineer out of that single tweet? You can get from Twitter, for example, the author. You can get the date and the time. Those are useful meta attributes that could provide some clarity about the tweet itself. You know, a tweet sent in the middle of the night might have a different point of view or a different language than a tweet sent in the middle of the day. If you run automated sentiment analysis, you can start to pull out things like specific emotions that are tagged from very well-known libraries like UDPipe. You can get the sentiment number, +1 to -1, and a scale along that line. And you can extract things like character count, word count, number of capital letters, number of emoji in a tweet, for example. Why would you want to do this? Why would you want to add more columns, given that we're already talking in many cases about, well, there's too much data and there's too much data for us to analyze? Well, the reason you want to do feature engineering is you want to be able to start chipping away at the why. Now, no amount of, let me put this very clearly, no amount of feature engineering can substitute for good qualitative research. No amount. But it can help enhance your qualitative research. It can give you more interesting questions to ask in your qualitative research, and it can eliminate things that might be questions you would ask in qualitative research if you can show that there's no relationship whatsoever. So, for example, time of day. If you do feature engineering and you have the data and you run it through an algorithm that says, hey, time of day is not important to the end result that you care about, then you can eliminate questions in your focus group about time of day. If there's complete lack of statistical significance about time of day, because say, okay, we don't need to ask that question. It can make your qualitative research more focused. The other thing that feature engineering does is it helps you start to understand hidden relationships within your data that you might not think to ask otherwise. If you use use or build your own feature engineering library, you can have it do very specific things like how many capital letters does something use. That's not something that a person who's analyzing, say, a book might think about, because it's not helpful. But think about the people in, for example, social media conversations. If you got a tweet that's all in caps, either the caps lock key was stuck on the keyboard, or that person's really angry and wants to yell really, really loud. Well, then I say angry, but they want to yell really, really loud. That's a feature. That knowing how many capital letters or what percentage of a social media post is all capital letters is actually could be a distinguishing feature, especially when you pair it with something like emotion. And if you have a target variable like number of clicks or number of retweets or shares or comments or whatever it is that you want to use as your endgame metric, then creating all of these additional features could help you understand What are the little subtleties within that text that indicate, yep, there's a there. There's something else to dig into. There's something deeper to dig into. So give some thought when you're doing your social media analytics, when you're doing your marketing analytics, when you're doing your blog analysis, your content marketing. Give some thought to how you analyze text, how you extract features, what features you look at. Remember, features are columns in the spreadsheet. And ask whether you've done enough on the feature engineering front to find hidden meaning. Now, a prerequisite of feature engineering is that you've got to have an algorithm that allows you to analyze all these features in combination and figure out which ones matter the most. At Trust Insights, we use 3 or 4 different algorithms depending on the type of data set and what's in it. But all of that software is free. It's open source software. Academia has done an incredible job, the academic world, of sharing working code for all of us to enjoy and use. It's important to make sure that academia remains well funded for that very reason. But the answers are knowable. And I think that's probably the most important thing of this entire Fun Fact Friday, is that the code is available, the data is available. We have to be the ones to engineer the features, unless you use deep learning, in which case you can do automated feature engineering. And it's just a matter of putting the pieces in the right order and having everything prepared well to do this extraction. What do you get out of it at the end? You get a model that says these are the top 5 or 10 things that create, actually not create, that have a high statistical correlation to the end metric you care about. So if it's retweets, for example, these are the 5 or 10 things that matter most out of this library of data. For example, I am working right now with a data set that is Medium posts, 1.4 million Medium posts, and this is a massive data set. And there's an end target, collapse, and then there's not much else, right? So I have to engineer about 50 new variables in order to do the feature engineering. But at the end of the day, I want to know what has a high mathematical relationship to collapse, and then we use that as the basis for our testing plan to say, okay, let's go and test to see if we do more of X, Y, and Z, do we get more collapse at the end on Medium? That's what you do with this. That's the value of this, is it gives you a much more focused testing plan, and that in turn means that your marketing can get more effective. So feature engineering is the name of what you do in data science to get at this stuff. Try it out. Dig into your data that you already have and see what's in there. See if there's value that is hidden within your data, and see if you can use feature engineering and then some machine learning statistical techniques to unlock that value. As always, please leave comments and questions in the comments box below, and subscribe to our YouTube channel and our newsletter, and I'll talk to you soon. Take care. Want help solving your company's data analytics and digital marketing problems? Visit trustinsights.ai today and let us know how we can help you.